One of the recent, I would say, insights, or might even say discoveries in economics, is the importance of institutions. You think economists talk about markets all the time and other things, stock markets, money supply, so on. But one of the real important discoveries is how important institutions are in society, in economic development, and economic growth. And of course, being in Italy, we know that Italy is the home of this great institution called universities, which has developed as the primary place around the world where scientific discoveries and learning are developed. But it's also particularly appropriate today, or I think particularly sweet, if I might use that term, that we're witnessing the birth of a new institution, maybe the wedding, but actually I like to think of it as the birth, where you have an institution brought together by a common cause, brought together by other institutions which have sponsored it and have given it both the intellectual and the moral support. So I think it's just a wonderful, wonderful occasion to see the birth of a new institution. We have too few great institutions around the world, so I hope that this small child of an institution will fulfill its possibilities. So what I want to talk about today is I want to talk about the problems we face in climate change. There's a whole range of issues, but I want to focus on one specific one, which is the international dimension, which is the place where we've made least progress in climate change. I think we've made many progress in climate modeling, understand mitigation, understand a fair amount about impacts, understand, thanks a lot to Europe about the role of different instruments such as cap and trade and carbon pricing. But where we haven't made much progress is in understanding the role of international institutions and what kind of international institutions are necessary in the climate area. So that's my theme today. If I go to we'll start, maybe I'll back up. I'm not sure if this is out of place or not, so let me just see if it is. Yes, no, I'll go back, I'm sorry. So let me summarize what I'm going to say. There are four things I want to say. The first is the climate science is solid. I mean, we don't need to, I'll spend a little time on showing some of it, but I think we don't need to have that debate, and particularly in that community. There are people who want to have it, but we don't need to have it. So that's the first thing. The second thing is that we have international institutions in place, or that have been in place, such as the Kyoto Protocol, the Copenhagen Accord, and the Paris Accord, which are in the nation of voluntary international agreements. But the main message I want to bring today is that those are actually not going to work. They're a flawed concept about how to run an international agreement of this kind. The third point is, however, that there are international institutions, and we've seen them, and we have them in place, that are functional, not voluntary institutions, but one that have both obligations, responsibilities, and costs of non-participations. I call those clubs, but maybe you could use other kinds of words for it, but it's a kind of club structure. And those have been successful, and we've seen them successful, actually the one I think of as the most successful is the European Union. And then the fourth thing I'll discuss at the end, which is a more technical part. I'll have 20 minutes or so of non-technical and 5 or 10 minutes of more technical, is how we might model that. So this is some of the work we've done at Yale to actually model the club or the coalition modeling, which is actually, turns out to be quite a difficult issue, but I'll show you some old and actually some new results as well. So let me just start with some of the more recent data. So here is, I think, I'll call the most important exhibit in what's happened in international policy, which is the emissions of global emissions. As you can see, they've been rising steadily over the period since 1960 with no break in trend. But perhaps this is more informative. This shows what's called emissions intensity, or the rate of decarbonization. This is the CO2 per unit of global output, global CO2 emissions per unit of global output. And there you can see there's a shaded region on the right and an unshaded on the left. The unshaded region on the left is where there have been no international agreements, and the one on the right is the period after the Kyoto Protocol, where there have been various kinds of international agreements in place. But the key issue is that the trend in decarbonization, there has been decarbonization, but it's been essentially constant plus a random noise at about a little under 2% per year. So what this shows is that up to date, none of the agreements we've had to date have put the kind of dent we need or the kind of inflection point we need on the rate of decarbonization. Now, where do we stand? So just to summarize the basic point before I get to the further argument. Well, I think the main point is that international climate agreements have not been effective, and that was shown in the last slide. You might say, well, they're in the future, or other reasons to be hopeful, but I think the basic argument is that they have not been. And what are the reasons, and what are the possible solutions? The basic reason, as I'll show in the next couple of slides, is because of the free riding that occurs when you have voluntary agreements for what are called global public goods or externalities. Since we had externalities introduced, we talk about global externalities. Global externalities are the ones that are the most difficult to try to solve. And when we have global externalities without binding agreements with consequences, then we tend to see free riding. So that's the basic reason. And what are the possible solutions? I'd say the most important solution would be to move from the voluntary model to the model with consequences, and that's what I'll be talking about a little later today. So if we think about agreements on global public good, so what's a global public good? It's something where actions we have spill around the entire world, and not only that, but the actions we take are anonymous in the sense that the impacts are independent of whether the emissions are in Milan or in New Haven, Connecticut, or in Beijing. So those are what we mean by international global public goods. Now, what I'm going to do here is talk about just to put this in the context of, since we are talking about research institutions and universities and science, just to flash up on the slide here some of the important developments that lie behind the kind of work I'm talking about today. And it goes into three classes. The first is interesting. The most important early development of this was cartel theory that was developed after the rise of OPEC. The second class is what I'll call theory, treaty, and the theory of stable coalitions. There's been a great deal of work on that, and some of the most interesting recent work is by Scott Barrett at Columbia. And the final is the theory and estimates for international climate change, and that includes three of the people actually in the room. There may be more, but the three I would particularly like to recognize. One of the earliest and most important pieces was by Carlo Carrera and Domenico Nascaldo on the theory of global public goods in climate. And then there's some of the most important modeling work are by Bossetti, Tavoni, and others using the WICH model, which has been developed over the last, 15 years. So, and then there's other work as well. But all of these are part of the rivers that flow into the kind of issues that I'm talking about today. So there's a deep and rich literature that relates to international agreements. Some of it is well known within our community, others are not well known, but it all points to the same common theme that I'm going to talk about today. Okay, so the key issue that we face in any agreement, a multi-party agreement, is to move away from a non-cooperative agreement to a cooperative agreement, from a non-cooperative and inefficient agreement to an efficient agreement. And this usually happens because of free riding. And free riding occurs when someone takes advantage of a common good by not paying a fee. I just was in Paris, and I was just standing waiting for the train, and somebody hopped over the turnstile, and I was too slow to get a picture. I wanted to get a picture of that. So I sat there for 5 minutes waiting for someone else to jump the turnstile. But free riding is something that occurs in many contexts, but the one that is gives rise to the term is, of course, free riding on public transportation, where there's not a suitable set of institutions to curtail it. And this syndrome is particularly important in the tragedy of the commons. Many of you know about Hardin's tragedy of the commons, where he actually invokes not the theory, not the game theoretical sources of this, which are in non-cooperative behavior, but more the idea that if you have a common resource, it tends to be overused and overgrazed. And that's because people don't pay for their social costs. So this is seen where you have no agreements at all. Now, there's a particular, so if we think of different communities, nations, cities, families, most agreements can be enforced politically, or at least in principle can be enforced politically. But the structure of international law, which is known as under the laws that were developed after 1648, the Treaty of Westphalia, are ones where you cannot legally require countries to participate in agreements they don't want to participate in. So the basic structure of international law is everything has to be voluntary. And so what we're doing is we're coping with that feature of international law, because what we want to do is we want to bring the reluctant people into an international climate agreement, but under international law we can't coerce them to do it. There's no point sending armies in. That's hardly the way to solve the climate problem. So this is the dilemma we're facing. How do you get people to voluntarily cooperate in an agreement for a global public good without coercing them? So let me talk a little about just now go from general global public goods to climate change and climate agreements. So there are two kinds of agreements to begin with. The first one is we have no international agreements, and there you just basically have a non-cooperative equilibrium. That's where everybody just does what's in their own perceived national interest. And the modeling we've done, widespread modeling on this, shows that even if countries did what is optimal from their own point of view, ignoring countries outside them, then that would lead to too small a level of abatement. So that's not surprising. That's basically where we are today. Now, the more surprising result, which is not widely known, is that if you have an agreement, but there are no costs of non-participation, what is the structure of this? So this is where you have countries can form coalitions, and then the coalitions, but they have to be stable coalitions in the sense that countries don't want to leave the coalition. They don't find it advantageous either to leave or to join. And this leads to what is known as the small coalition paradox, which is that you can support coalitions of 2 or 3 countries, but it turns out you can't support larger ones because their tendency to free ride from this takes over, even if they're cooperative, rather non-cooperative agreements. So this is basically where we are with the Kyoto Protocol, the Copenhagen Accord, and the Paris Agreement. We're just sort of confounded by the small treaty paradox, which is that we can't get people to participate because even in an international agreement, there's this tendency to jump. And this is what caused the unraveling of the Kyoto Protocol. So this is a slide that shows the unraveling of the Kyoto Protocol, which was subject to free riding. So when the Kyoto Protocol was first negotiated in 1997, this shows you the fraction of emissions, global emissions, that are covered by those countries that had accepted binding. It's not participants because everyone participated, but those who actually had and agreed to have binding emissions limitations. And as you can see, it started out pretty large, roughly 2/3 at the beginning of 1990, a little more than 50% when it was negotiated. But then it declined, but it also declined with some jumps. And the jumps is when countries left it, the United States being the first arrow, and then the second arrow, which many people don't know about, which is that also Canada left the Kyoto Protocol much the same way the US did, because it couldn't meet its objectives without too high costs because of the oil production. And then, by, of course, at the end of 2012, it just basically expired. It just died. So this is an example of free riding at work on an international treaty. And what was the problem with it? There were no consequences if you left. The environmentalists get mad at you. Maybe some of your allies get unhappy. But essentially, there are no tangible political or economic consequences of leaving that agreement. Okay, so this leads me to the idea of how we could reform or change international climate agreements so as to move from the voluntary agreement model to the model where you have agreements, but there are consequences for non-participation. And so this is what I call a climate club. And it's a club in the sense of an organization. All of us belong to probably different kinds of clubs. We belong to a club that's called a nation, a club that's called a family, maybe some other kinds of clubs. EU is a big club. The WTO is a big club. NATO is a big club. So all these different kinds of clubs. So what we need to do is to figure out how to design a club for an international climate agreement that is effective and has incentives for countries to participate and to meet the agreement. So that's the issue. And the simple answer is you need to have a club where, or an agreement, where non-participants are penalized with some kind of sanction or other kinds of costly action by the members of the agreement. And so this leads to the question, what kinds of penalties can you use? So in the climate club, I'm going to talk about it. It's a top-down treaty. It's designed similarly to the post-World War II institutions, not so much like the EU, it's bottom-up, but the World War II institutions, the World Bank, IMF, Bretton Woods, that were top-down treaties. And now in terms of sanctions or penalties, I think both history and law and experience suggest the only viable penalties are trade sanctions. I mean, nothing else has proved to be durable and useful. And then the question is, what kind of trade sanction? And here there are two different possibilities. The one that commonly talked about is countervailing duties, where you put tariff on the carbon content of imports. It turns out that that's an ineffective sanction, and I'll show you some results in a little bit later. And the actual one that I will talk about and is more effective is just a uniform tariff on the imports of non-participants into the participating region. So you have a club with agreement as to what climate policy should be. You have non-participants who are not in the club. The penalty for not being in the club is that your imports into the club region are met with a small uniform tariff. So I'll give you a little bit of the modeling, and the next 10 minutes or so will be a little more technical than the first 10 minutes. So, but I want to talk about, since we're in a research institution, this is another example of the kind of modeling that economists and climatologists and political scientists and game theorists do. And this is an example of what I call a coalition model. I call it the coalition dice model. And it's got a simple structure. It's got 15 different regions. And it's only one period because it turns out it's an extremely complicated combinatorial problem. So it turns out the solution of it is very different. So it's actually quite a simple in principle, but actually quite difficult to solve in practice. And now, so I'll start with this slide, which is kind of a key slide. So let's say you have, I'll use this, I'll explain as I go along. So let's say you have a climate club where you say, we're going to have a policy. The policy is that each participating region or country must have a minimum domestic carbon price of $50 a ton of CO2. So that's the price of admission to the club, so to speak. Those are the dues to be in the club. And you have to have that, and it has to be validated for you to be a bona fide member of the club. So the penalty tariffs are then shown here. This shows the participation rate, the number of participating regions, as the tariff rate goes from 0 to 10%. So you can think of 0% is basically the Kyoto Protocol or the Paris Accord, how many countries would participate in that if there were no sanctions for participating, and you can see basically the answer is none. So that basically says the model shows what reality shows is that countries are not going to participate in a strong international climate agreement if there are no consequences. So the second thing is then you see how the number of participating regions rises sharply as the tariff rate increases, and it gets to 15 at about 7% tariff, but it gets to a very high number by the time you've got to 3 or 4% uniform tariff rate. So this shows nothing very surprising here, that the number of participants rises as the tariff rate rises. That's because as countries trade off the costs and benefits of participating, it becomes more beneficial to participate because you avoid the tariff losses. And on the other hand, if there are no tariff losses, then there's no reason to participate. So this shows you the same thing, but shows you for different tariff rates, $12, $15, $50, and $100 a ton. And the interesting feature here, which this is one I had not anticipated, is that the effectiveness of it goes up and then down. So it's very effective at a low price, carbon price. You get everybody to participate easily, but it's a low price. You go up a little bit, you get almost everybody to participate. Medium price, a little higher, $50 a ton, you get almost everybody to participate pretty easily. But then as you get a very high carbon price, then the participation rate drops off because countries would rather, it's actually two effects. Countries would rather not participate because it's too costly to have the abatement. But then also you have a participation effect. As one country drops out, the effectiveness declines, and so you kind of shoot to the other equilibrium. Anyway, this is where I ended when I last did this research. So from now on, there's some new thing. So what you see here is what I call a carbon tax Laffer curve, which is as the international obligations become stricter and stricter, then basically countries first participate and the you can think of emissions reductions rise or emissions fall. Let's say emissions reductions rise, the effective global carbon price rises, but then after a point it falls. And so this shows you for 3 different tariff rates how you have this carbon tax Laffer curve, which shows that there's this trade-off, and the trade-off occurs depending on what the carbon tax is at tariff rate is at lower or higher carbon taxes. But the interesting thing is that you cannot, in this approach, support an extremely high carbon price, carbon tax with the trade system. So this was one of the places where I left off when I first did this research. Okay, so the original model suggested that you could support a $50 ton carbon tax, but above that it would get very difficult. So anyone who knows this area and has looked at the recent research knows that $50 to $100 a ton is not going to support our ambitious objectives of 2 degrees or 1.5 degrees, probably not 2.5 degrees C. It's just too low a price. So does this mean that this mechanism is insufficient and it needs to be supported by something else? So that's a question I wanted to ask when I come to talk to my colleagues here. Okay, so what I thought about in preparation for this was, well, that's a one-period model, but it's for 2015. What would happen as we extend it over time? I can't extend the main model because it's too complicated, but you could do a smaller model. And what the results suggest, and I'll show you in the next 2 slides, is that the Climate Club can support ambitious targets if you have the Climate Club with some kind of penalty like tariffs, but also only in the presence of rapid technological change. So it has to be not just a binding agreement with penalties for non-participation, but it has to be also rapid technological change that reduces the cost of participation over time. Okay. So what is the reason? You can think of, what I'm going to do is show you a concept which is called a supportable emissions or carbon price. And by supportable, I mean something that's the break-even for a country between whether to participate or not. So it's the maximum level of carbon price or the maximum level of carbon emissions that one of these international regimes can support. I should say, this is really not only about trade and tariffs, it's really about sanctions and what kinds of sanctions are necessary or penalties are necessary to induce countries to participate. It just is an example of that, but it shows the trade-off. And so I'm just do one equation. I apologize for those, but it just give you the basic result is really simple. The supportable emissions or supportable emissions reduction or supportable carbon price is the point at which the abatement cost exactly equals the cost of the tariffs. So at that point, you're indifferent. If the carbon price is higher than that, then you won't participate because it's cheaper to accept the tariffs. If the carbon price is lower than that, or the emissions are lower than that, then it's more economical to participate. So this gives you the break even between those two. And it's a little bit complicated there, but the key variables there are basically the cost of emissions reductions, the tariff rate, and the cost of tariffs. The other things are, I won't get into. Just it's not a terribly complicated equation. It looks complicated. It's not terribly, but it shows you what the key determinants are as to whether what the break-even level. One interesting result about this is that it turns out that output drops out because it's on both sides of the equation. So it's just the scale variables that are important in determining this. Now this is a function of the key variables that this is determined by are the trends in trade, whether countries are open or not, the decarbonizing technological change, that's the technological change I mentioned before, and the decarbonization rate. So what I did is just, for this purpose, I did 10 regions, equally sized regions. That gives the basic results of the model. And the key policy variable is the R&D, other than the club, is the R&D to support carbon-reducing technological change. So it's decarbonizing technological change, not general carbon, not energy, but decarbonizing technological change. Maybe you can think of in some terminology, reducing the price of the backstop technology. And so I showed you 3 results, one for no technological change, one for 2%, one for 4% per year. And those are quite ambitious, but not outside of historical experience. All right, so the first shows you for the year 2050 what supportable emissions are under each of these, and starting at projection in a baseline of about 50 plus gigatons per year. You can see that if there's no technological change, you'll have some that shows at different tariff rates what the supportable level of emissions are, and if there's no technological change, you can't get down to 0 emissions. But if there's rapid technological change, you can get down to 0 emissions with a relatively low tariff rate. And last slide shows you over time what the supportable emissions look like under the 4 regimes. So this is starting from 2010 and ending in 2060. The baseline is the blue line, and the red, gray, and green lines show you what supportable emissions are with no technological change, modest, and high technological change. So the basic message then, and I'll summarize. The first is that the Kyoto Protocol type agreements are ones that will lead to minimal abatement because of free riding. So that's the key, unfortunately pessimistic note that we need, that has been brought by game theorists and treaty specialists and modelers into this discussion. However, strong incentive-compatible agreements are possible if you have these along with penalties, such as trade penalties. And some simple multi-period modeling suggests that you need 2 things, actually. I think it's quite intuitive, but two things. You need not only this club-type approach where you have abatement targets plus incentives that work through penalties for non-participation, but you also, if you're going to meet that will get it started, but if you're going to meet the international targets, you need very rapid technological change to reduce the cost of meeting the agreement. Thank you very much.